Hi everyone. Today I'm gonna talk about aldol reaction. Aldol reaction. The name aldol comes from two words, ald and ol. Ald comes from aldehyde and ol comes from alcohol. So the name aldol comes from the product that forms when aldol reaction happens, and it has both aldehyde and alcohol functional group. It can also have ketone and alcohol functional group. In that case, we call it ketone. So when aldehyde or ketone that contains alpha hydrogen reacts with another molecule of aldehyde or ketone with or without alpha hydrogen in presence of a base, it forms either aldol or ketol. Afterwards, when we heat that molecule, it loses a small molecule as a form of water to form alpha beta unsaturated carbonyl compound. So if we stop here at the first step, we can call this reaction as aldol addition because two aldehyde or ketone molecules join together to make aldol or ketol. When water loses, then condensation happens and an alpha beta unsaturated carbonyl compound forms. Before we talk about a specific example, we need to review some properties of aldehydes and ketones. So we just mentioned in aldol reaction, um, alpha hydrogen, the presence of alpha hydrogen plays a vital role. So here is an aldehyde. You can see the red hydrogen is the aldehyde hydrogen. This is not alpha hydrogen. The carbon that is directly attached with the carbon oxygen double bond is the alpha carbon, and any hydrogen that is present on this carbon is called alpha hydrogen. Now, aldehyde and ketones are usually electrophilic in nature due to the polarity difference between carbon and oxygen, and the carbonyl carbon of aldehyde and ketone acts as an electrophile. When you put an aldehyde and ketone with an alpha hydrogen in presence of a base, the alpha hydrogen is acidic, so the base grabs this hydrogen as a proton and form an anion called enolate anion. The name enolate comes from enol. You guys already heard about keto-enol tautomerism. So the enolate anion acts as a nucleophile. As you know, nucleophiles should have excess of electron. So in this resonance forms, you can see that either the oxygen or the alpha carbon has negative charge. Let's jump into an example. When benzaldehyde reacts with acetone in presence of sodium hydroxide and heat, it forms dibenzalacetone. If you look at benzaldehyde, it doesn't have any alpha hydrogen. This carbon has 4 bonds, so it doesn't have any alpha hydrogen. But in acetone, both the carbons, this is alpha carbon, this is alpha carbon, and on both sides it has 3 alpha hydrogens. So benzaldehyde acts as electrophile because it cannot donate any alpha hydrogen. But acetone can donate its alpha hydrogen to sodium hydroxide and can form enolate. So acetone will act as a nucleophile in this reaction. What happens here, as you can see, alpha beta unsaturated carbonyl compound happens. So this reaction is an aldol condensation. And aldol condensation happens twice. For this case, benzaldehyde reacts with acetone. On the first aldol condensation, the alpha beta unsaturated ketone on the left side, and on the second aldol condensation, the alpha beta unsaturated ketone forms on the right side. And 2 molecules of benzaldehyde has been used in this reaction. So as you can see, the benzaldehyde is the excess and acetone is the limiting reactant. Let's talk about the mechanism. The mechanism looks scary, but it's pretty simple. The alpha hydrogen present on acetone has been extracted by the hydroxyl group or present in sodium hydroxide to form water, and the enolate anion forms. So this is the step 1, enolate formation. And then since the enolate acts as a nucleophile, it attacks the electrophilic carbon-oxygen double bond present in benzaldehyde, forming a species like this. So step 2 is nucleophilic attack. On step 3, the formation of aldol or ketol. The anion grabs a proton from the water that was generated here, forming a ketol. If we started with an aldehyde, it will generate an aldol. In step 4, when we heat this molecule, the generated hydroxyl group here will abstract or remove a proton from this carbon to form a carbon-carbon double bond. So we will form a alpha-beta unsaturated carbonyl compound. So the step 4 is formation of alkene by condensation, so removal of water. If you repeat step 1, 2, 3, and 4 on the other side, so we started on left, right side. If you do the same thing on the left side, enolate formation, nucleophilic attack, then ketol formation, and then condensation, you will gonna get dibenzalacetone. So that's about the mechanism. In this reaction, since you use sodium hydroxide, so it's a corrosive, so use proper safety measures. You need to carefully measure both the reagents. You need to use dry glassware, and you need to maintain 60 to 70 degrees Celsius temperature using a hot water bath. Thank you for listening.